kind of understand my Vim. Like, why does the font change so much? It's so weird. Let me see if I can start it again. There we go. I guess that's closer. All right. Okay. I think we got everybody. Hey. Let me do my pinned message as usual. Nothing really. It's most likely gonna just cause a lot of winds. It's further out, but it's a pretty big one, so it's kind of... And also, I'll just say, the power company is full of shit. You know a storm's coming, and they use that as an opportunity to turn shit off so they can do maintenance. Because there's no way that... We get winds like this all the time. The winds are not even that bad, right? And there's no power out. But they send an email, and then suddenly there's like every hour, almost exactly on an hour. So you know they're in there like, okay, substation 4, switch it! Turning the power off. Let me get this pinned message going. Okay, I'll be right back. Let me make a little coffee. Let me just do a little timer. Wait, why is the timer over there? Timer should be over here. Okay, we are back. Let me get to the code. I'm working on map. I will take a look at the algorithm a bit, but I think I need to grab that Python code and try to run it. Also, okay, well that's never gonna close now. Wow, this is easily like the worst piece of software ever. This thing has, like, every once in a while, it has a secret dialogue hiding somewhere. I can't find it. So I have to go into Task Manager and kill it. It's like whoever wrote it just uses a Mac, and then they just throw it out on Windows. Like they got some kind of cross compiler that makes a barely working Windows build. Okay, so that's better. All right. Yeah, let's take a look. Let's make sure that runs. Also, I was researching matrix libraries, so I might try to pull one in and see if I can redo this with a more professional, actually good matrix system. Oh, also, we gotta make sure the audio is good. What the hell? Am I looking for sound mixer? Yeah? Okay. Yeah, I could probably do that. Yeah, that's interesting. Yeah, minus the 2 hours to get a matrix to work. I don't know, I'm actually kind of weird like that. I think a lot of people, when they watch me code, it seems like I'm kind of bumbling around like a moron for the beginning, and then sort of the madness congeals into something, and it's like boom, and just like goes. I And I've worked with other people, like pair with them, and they're like, oh, this is so annoying. Just do this. And I'm like, just wait. And then like I code and I code and I code and they go, oh, okay. And I don't know why I'm like that. It's kind of strange. Okay, so this does not work. But let me just look real quick. Maybe the answer will jump out at me. And then if not, I'm going to grab that Python project. It is. I always tell people, like, don't try to shame yourself or constrain yourself, like, and say, I should code this way. And actually, honestly, I think people just have a misunderstanding of how to code. I think you have to kind of like explore and try things and rip things down and build them back up. But they think you just start at the top and go to the bottom and then you're finished. And it's not how it works. So I don't think anything I do is wrong. It's just more that a lot of people don't understand it. Yeah, they look at it, they're like, this guy's a moron. And then a couple hours in, they're like, oh, okay. No, he's not. It's like my coding style is drunken kung fu. It looks like I'm drunk, but actually, it's genius. All right, let's take a look. Let me see what we got. Did I... No, I'll have to grab... Let's go over here. Let's kill that. Kill that. Let's confirm I got J and I. Okay, that's all looking good. Let's get the Python code up here. That's not it. Oh, did I do this? I did do that. Actually, let me fix that because I'll move the code to the wrong place. Okay, cool. Let's boost that font so people can see it. Yeah, I think it's something like that. I think another thing about it is I try to practice like having a personal process. And I think a lot of programming for most of probably the last 20 years has been about people advocating these team processes and trying to say that that's personal. So I think since most people code at work and the only thing they know is work process, they don't kind of understand that there's sort of like a personal process. So they watch me do stuff and they're like, well, where's his test first? And why didn't he plan this all out? So I think it's more they just haven't seen that. But then, I can also understand why people think that's totally weird. Okay, Python here. All right, we're good. I'm sort of on the clock, man, because I guarantee that power is going to go out in about an hour. You watch. Okay, so we were thinking that it's something to do with type conversions and things. Let me just scan real quick and see if something jumps out at me now that I've had time to sleep and work on some other stuff. Let's see, if not limit. Total pixels is that. I'm not using total pixels, so that's fine. Yeah, I think it's going to go pretty far north from the south. I think it goes up to Georgia, Alabama. I know Georgia's pretty freaked out. But where I'm at, no, we'll have lots of heavy rain and stuff. I might try to do another recording for painting sessions. But otherwise, I think this area doesn't really get hit. It's not like Miami. Miami gets like obliterated every couple of years. Yeah, I can't really see any difference. So we're going to basically create a little test right here and kind of replicate my test that I have. Now we're going to grab these. And we're going to want, okay, let's swap those. I'm just going to make kind of a janky little test that does the same thing. We got to make sure we match the parameters, input map, walls map, and limit. And map, walls, walls. Oh, don't need that. Okay, so then we just reformat this. I was really on fire today, man. I did like 3 exercises in the regex course. Started the next one in the C++. It was like every time the power went out, I was like, God damn it, that was like a whole hour. Trying to fix my UPS. I just need to buy a new one. It's like real bad. Okay, and then... Wait, why am I only doing the insides of that? Yeah. Okay, so in theory... I don't think Python can do the deep equals thing, but we'll just print it. Oh. We'll just do a simple dump. Oh. The indentation on the Python code. This is art, man. Don't harsh my buzz, bro. Let me see if it even works. Oh, I need NumPy. Shit. Oh, I don't even have Conda. How do I not have Conda? Shit, I think I fucked up my install. I've been running that installer, testing it. I think I've probably deleted it. Portmaster. Okay. All right, try it again. Okay, I think that works. All right. Yeah, I suspect this code might have bugs. That might be why it's not really working. List object has no attribute shape. Okay. Is that on closed? Oh, no, I'm doing this wrong. This has to be a NumPy matrix. Let me go look at. Shit. Oh, yeah, there's a whole bunch of them. There it is. All right, MP array. Is this the same code? Yeah, it looks like it. Okay, yeah, I'm just gonna copy pasta that. Actually, let me just confirm I didn't like fuck this up. Yeah, that looks right. Okay. Okay, that's good, that's good. And then we don't have to use this in calculations, we'll just print it. Oh, and then that's, okay. Yeah, it looks like it's working. Oh, that prints correctly, so I'm going to replicate that too. Okay, so the Python code is doing the right thing, which means there's a difference in either how the C++ does things, or I just kind of goofed up some variable somewhere. So now we just got to print out what it should do. Let's switch that over there, and then what we're going to do is we're going to print out oh, that's interesting. Let me just confirm when it makes new array. And let's dump. I'm going to do one more little mod to this. Oh, I got a question. When you guys first came to look at my stream, did you have to see an ad? Like, does it do a pre-roll? But sometimes you do. I've had a few people say that if you just run adds in the middle, yeah. See, I might do that. I'll have to research how, but apparently, like, people will go to a channel. Yeah, interesting. So the only downside is if you watch one ad at the beginning, you don't watch any more for the rest of the stream, right? Is that usually how it works? But if you do ads in the middle, you have to do 3, and then the pre-roll goes away. So more people are willing to kind of join your stream if that happens. But then you kind of have to pause. I'd have to be able to see... Yeah, I'd have to be able to see if an ad is going. So I may make that change for the next stream. Interesting. Okay, so we got this. I swear, dude. Alright. I'm just a short rant. I know C++ is flexible, but why is it the only language that you can even replace the string? Like, this makes string just a standard thing. I don't have to include anything or do anything. It's just there all the time because you use it all the time. Okay, rant off. Okay, cool. So now we can just do that and that. All right. Okay, let's see what that says. Oh. That's probably the problem. So Python, when it does new array, it's full of zeros. So why the fuck is it using a function called ones? What the fuck? Okay, so then... And my new array is full of ones. Alright, so that's the thing. I'm pretty sure that's what's doing it. The hell, that can't be right. Okay, so I need to actually look at what the hell this thing does. It seems to make a completely different array. That was a one-dimensional array with zeros in it. Created with the function called ones. Yeah, but also it's a different dimension too. Is it? Wait. No, this is the whole thing. Yeah, all zeros. Jesus. Alright, well that's probably what's doing it. I can bet you anything. Where is that? So I wonder if that... interesting. That's doing a matrix multiplication of ones times limit, but limit is set to 0. So if you set it to something greater than... Yeah, so it's correct, it is ones, but then it's doing matrix math that gives it times the limit. So if I set limit to like 10, it'll be full of 10s. But since limit is 0, it's getting filled with zeros. Okay, so we'll simulate that, and then I'll see if I can make that work. So the way to do it would be to initialize mine to limit, right? Because that's basically what this is doing. This is a matrix of ones times limit. So if limit is 12, it's just a matrix of 12s. Okay. So then that would explain why the final matrix has ones in those spots where the walls are. there we go. I told you, man, you just gotta sleep. Sleep. That's it. Yeah, so then that becomes zeros. Now if I set limit to like, and this also solves the problem that I was seeing where the way the Python code is written is if you set limit, then the walls would be set to whatever your limit is. Yeah, so if I do let's go down here and let's set limit to 10. And then also go to the test and set limit to 10. Okay, so we'll run the Python. Yeah, so see, it starts as 10. Awesome. And then run our test. And it fails. Interesting. Okay, so let's go look and see. Oh, but that's because I'm saying my expected shouldn't have 10s. So this is actually corrected. It's just I need to... yeah, that's fine. Because this is what's supposed to happen. So now my walls are set to 10, which basically makes it so that if you're doing this in a roguelike, your character will never go to those things. And your calculations will only be, I think, like 10 squares out from where you are. Okay, this is running correctly. Fantastic. So then if I were to make the test work, I think I should do this. Yeah. We'll do like a few permutations with the test to confirm. Yeah, I knew it was something simple like that. Very easy. I'm going to throw a comment on there. Yeah, now it works. Awesome, awesome. Let me throw a comment on there so I don't like delete it. Okay, so if I do bring in a matrix library, I'll just replicate this. Okay, so now we have a working system. Let's beef up the tests. Probably want kind of a test harness. Yeah, we want to have like a bunch of these where it's like map walls expected, map walls expected. I wonder if I could load those out of a JSON file. Right? It would be... That would probably be way more code than necessary. There'd be more code. We could try it, but I think, yeah, what would it be? Let me see. It's going to be something like probably a list. It's going to be input. And walls. No, this would have to be, yeah, a list of objects, input walls, expected. Yeah, and then I could just basically make a shitload of these, and anytime I run into a wall that's like a configuration that's a problem, I throw it in the test, and I just throw it in this JSON file and solve it. Alright, we're going to do that. That'll be fun. Okay, and we got walls. How was that? Oh. All right, so we gotta turn this into this. Let me pull up how I do this in Turns Tar Pit. All right. Because I believe, yeah, I was doing that. Okay, cool. There we go. I also need all right, let's make that much work. All right, looks like we have the luck of the storm on us. So far, so good. But it's not supposed to hit till about 6. All right. Okay, so that worked. We can load the data. Now we just have to... This will be interesting. How the hell do I convert the JSON to a vector? I think I manually have to do it. Now let's get the keyboard. It is a mechanical keyboard, but it's the happy hacking, so it's not too loud. And I have a piezo sensor. It's like a contact microphone, and it's stuck to the keyboard. So I'll tap the sensor real quick. So the mechanical keyboard is pretty loud, and also I type like a gorilla, but the piezo sensor kind of softens it, so it sounds nice. I feel like it makes the stream a little more, I want to say, like realistic, right? Instead of this characters kind of flying on the screen. Yeah, print line. Yeah, let's just make sure we got this. I got this idea right. Let's just do the key. The key. Always forget that. Yeah, it should be key. Well, we'll just see. C++ will complain to me with an insane error message. Yeah, okay. Let's let's go look at the docs. All right. Interesting. I think I am going to have to do an iterate or something like that. STL like access. Oh, it has to be auto reference. And items. That's what I'm missing. Oh, why did that compile though? It should have totally ate it. I think that'll do it. We should see it print out the 3. Then we just got to extract each one into those 3, and then we can just write a JSON file that can test all the maps we want. Oh, it's 0. Oh yeah, so that's an array of dictionaries, objects, that kind of thing. So this is, let's call that test list. And then auto, yeah, reference. Actually, I think I don't need items, because that's a list. Huh, it's kind of inconsistent. I don't think that's going to work either. Oh, okay, there you go. So then what does items do on a list? Weird. Anyway, let's run it and see what it does. Okay, we should get, yep, expected input walls. Cool. Awesome, awesome. Okay, alright, so now we have that. We just need to construct these 3. Oh man, this is gonna be brutal. Let's just see if we get lucky. Just see if there's some magic behind Senior Loman, and he has thought ahead of us. And see if that works. Yes, we'll see if that If it magically converts it to vector of whatever we want, then hey, we're done. Nah, didn't think so. Oh, I'm dumb. Of course I'm dumb. I don't want to iterate through each of those because I know what they are. I want to do this. Okay. No, that's right. This shit. Wait, I'm totally getting this wrong. Yeah, this should be... Data is a list. Yeah, right. Let me see. Data is a list. So then this should be the test. Okay. And then the test has 3 keys. Okay. Now let's pray and see. Nah, I didn't think so. I didn't think so. Oh no, but that could still be right. Okay. Is it key and value or... No, actually I don't even need value. I just need that. Okay. I'm overthinking this. The weather's dicey. We'll see how this rolls. It's not too bad. Storms, I think, hits about 6, but the power is cutting out. There ain't no way that works. I'm gonna be blown away if this just like just magically converts to a vector of vector. Right, I'm gonna comment this out because I know I'm gonna need that. But if this just works, man, then everyone who hates C++ can just suck it, because this, I'm pretty sure this would not work in a lot of languages. Okay, we're gonna do matrix walls equals test walls, and matrix expected equals test expected. All right. I need to get the game over here. Turing Star Pit. Maybe that's what we do tonight if I have power. We'll get Turing Star Pit to work. There ain't no way that shit works. This is awesome. All right. Let's see if it actually runs. It might only be converting the surface of it. Really? That's awesome. I almost don't believe it. I can't believe that shit actually worked. Okay, so that means we can make a bunch of those really easily. So when I run into any potential issues, like if I run into a configuration or like a wall that doesn't seem to do anything. Also, I have no idea how this song has not been copyright striked yet. This is totally a Portishead song, right? So let's simulate this. Oh, I would need one more setting for limit. Yes. Yeah, limit, because we need to be able to modify that. So let's do int limit equals test limit. Okay. And not that. So then here as well, this should be limit 0. Okay. My head's kind of in the way, but there we go. This JSON file has the limits. Has everything we need. We run this. Yeah, maybe. Although it's pretty stable. It's actually, after I sort of sorted out the how much the RAM should work, like how fast it should go, I think the CPU couldn't handle the RAM speed. Oh, also I'm still doing that. And get rid of dump there. Okay, close. Oh, did I not update expected? Yes, I didn't. So expected is supposed to be 1, right? 1 and 1. Okay, awesome. Kind of got a weird output. Let me just make sure I can sort out how it's supposed to work. It's supposed to be 0. Let me look at what the Python outputs. Yeah, it's supposed to be zeros. All right, so I put 1s. It should be 0s there. Alright, so that makes doing tests a lot easier. Just lose everything? No. But you know, I could see doing like little challenges, like write a grep tool without dying. Alright, cool. So now I can just output those. I think I'm also going to do one more thing. If the output from the require is a little hard to read, so let's do that. Okay. Let's do that, make sure it works, then make it fail on purpose. Alright, not as hard as I thought it would be. I'm actually very impressed that that library converted to a nested vector. Very nice. Okay, so let's just turn this into like 100 or something. So that should fail now. Awesome. And when it fails, yeah, we get the error. Okay, perfect. Alright, so now we'll just like have find a bunch of maps to work with and keep testing this. So let me commit this, and then what we want to do is kind of clean up the C++ code because it's converted from a Python project. So you kind of transliterate it, and then you go through and you make it C++, like you utilize what C++ has to do stuff. right. If people want to see that code, the link is in the pinned comment. Let's load up. That. All right, let's take a look at this. That's fine, that's fine. That's fine. That should be okay. Yeah, that's fine. That works because it's the only thing that OpenPixels does. That's good. What was I thinking would probably need to be? Oh yeah, that's while loop. How would I do that as a for loop? And should it be a for loop? I think that's kind of it. Right? Yep, that clears next open each time. Okay, we'll compile that and then I'll see which is quicker, clearing it or making a new one. Or which is better, I should say. I'm not too worried about performance at this point. I think if I want performance, I'll go use a library like Eigen or there was another one, game template library, something like that. Of course, I broke it. Oh, interesting. Yeah. You kind of need the counter outside. Okay. It's kind of not getting you much. Yeah, you're effectively just writing a while loop. Oh, I don't need this. That's too many. Yeah, you're kind of doing that. I mean, is it really better? I mean, I guess because you can see the advantage is that you can see that it's getting incremented here. So you know that you can see on one line. But I'm going to do a comment here. I'm going to say leave this here because it's used down there. Okay. Let's try that. Compile it. Okay. Make test. Okay. Yeah, I don't think clearing the pair list and then redoing it is a big deal. I mean, technically you could do... It's going through all the pixels. No, that's going to be different. I was thinking you could do open pixels clear, but that's something different because it's processing the pixels that are already in the open pixel list and then updating a new pixel list and then changing it. So, yeah. And I don't think Vector has a sign until C++ 13. I should look at that one too. Okay, so No, it has a sign. Okay. So is that better than equals? Let's look at what the equals operator... And if they say... Yeah. Yeah, I don't know. I don't think you're really getting much if you do a sign or not. I guess maybe you could do move. Alright, I'll just leave it. Keep it simple, and then if it becomes a problem, I know where to go. I think that's really it. I don't think there's much you can do from there. Okay, so with that in mind, though, let's take a look at a couple of these. We'll see what this is. Oh, this is for like real maps. Oh, interesting. Okay, alright, we'll skip that. Then, I believe it was Eigen. Eigen is available within Mason, so it's really easy to pull in. Eigen 3.4. See what it's like. That kind of looks like sort of the same thing. It's got its own matrix and vector. Because it could be useful to go and see if there's a faster linear algebra version of this algorithm. Like, I just know that there's like, oh, if you just do like these 5 operations on a matrix, you get the same thing. It just looks like that. Anytime you see a shitload of for loops over a matrix, there's definitely some linear algebra. I am just not strong enough. Yeah, this looks pretty nice. Now the downside is it wouldn't really work with the JSON thing, I think. Alright, we'll keep it simple. We'll just come back to it, and if it becomes a problem, we'll look at using one of these. This was the other library, the generic graphics toolkit library. Generic graphics math template library. So this seems to be very oriented towards graphics, which I'm not really using too much of. I mean, it's like a text game, right? But the API looked pretty nice from what I could see. So this would be another one to check out. But the documentation seems like... Let me see. Let's go here. Right. Yeah, so you can see it has... These are things that are typically more in graphics. But it does have a generic matrix. So in theory, you can just multiply it times that. You're done. And vector. So anyway, so those are 2 options. I think later on if I find, oh, there's this crazy high-speed vector linear algebra version of the Dijkstra algorithm, then I'll just convert this. I think for now, we are good. Okay, so let's try to use the damn thing. mean, that's the whole point. Oh, I was reading about this too. Still don't understand it. Apparently, if you name a variable a certain way and return it, then it'll get copied immediately. You don't need to do copy move. I don't get it. Okay, so we got that. Let's go to the main. We have ourselves a map. So we can convert that to a map. Let's just see if we can run the algorithm on it. So let's convert this to using the matrix syntax we got over there. And then we'll run the algorithm and see and like do some kind of like output on it. And then the next thing to work on is the BSP algorithm for map generation. Okay, I don't think we need that. Let's replace that. We're going to do okay, so this is going to be the map. It's going to be 1, 2, 3, 4, 5. Let's make it a 6 by 5. Let's see, we're going to do 4 more. Yep. Okay, I botched that, but whatever. Okay, so that's going to be our wall map. Let's make sure we name that walls. Then matrix. Input, so we need to have where the character is, which I believe we set everything to 1 except for where we want to place the character. Okay, so because that determines where everyone goes. So we copy this. Actually, it'd probably be quicker to do that. No, actually this. And then let's put the character here. Okay, so we have an input, we have the walls, and then we just have to process that. We get the output. All right, so first we're going to change the renderer. Let's do input.size. And I'm going to say if, no, let's say walls.size. So dude. So if it equals 1, then we want this. Otherwise we want that. Yeah, we'll just do that for now. Okay, so that should do. Now, actually, we need to do this more down here. Yeah, that's going to be individual character. Okay, cool. Yeah, because it's n of m. Yes, in theory that should work. So that's going to give us a little square room to play with. Oh no, we have to do J I. Oh, it takes a string. Okay, no problem. I think I'm just gonna make a header file of, call it no BS, and it just does shit like, I'm just always gonna use strings, so just as using standard string. Okay. So got a little input in that map. Let's see if we display correctly. Make sure our test still works. Good. Close. I think maybe my screen size changed. Yeah, something like that. Okay. Let's make these 40. And instead, that'll move it up. No, we'll do 20. It seems like it's pushing it down. Maybe it's getting clipped. Okay, let's try that. Okay, cool. It's still not doing the whole thing, so I must have some sizes wrong. Not bad, though. Okay, we'll have to make this 20 as well. Huh, interesting. Why does it do that? And I don't need it to be yellow, so we'll just do that. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 by 5. Oh, that's right. This is the inner block, so I need to get rid of that. Okay, great. Okay, cool. So we got a dude. I just got to move him back a little bit. Okay. Maybe just do this. Well, actually, we should tie it to where... Oh, that's the wrong coordinate completely. Yeah, so then we need the input map. We'll just say where the character is at. So they are at 0, 1, 2, 3 by 0, 1, 2. Okay. I think that'll work. No, and this should be ×2, not ×4. All right, we'll have to make a translate function that translates from FTX UI's thing. Yeah, okay. It's still off. Is it? No, I think that's right. 0, 1, 2. 0, 1, 2, 3. Probably just a dumb off-y1 error. Okay, that seems to be about right. 0, 1, 2, 3 by 0, 1, 2. Yep, there we go. Okay. That's a good question. I hope not. I hope they're not indexed by 1. Yeah, I don't know. Anyway, all right, so we can draw this. So now we need to just do the flood map on it. I kind of want to make that map bigger though. Get a little more to play with. Yeah, let's double its size. Yeah, we'll do this. And flip that to 1. Yeah, there's some languages that, like, it's understandable people have a hard time grasping 0, but they quickly run into problems when they become more advanced. So you're not really saving them much. Okay, we're gonna make this kind of like a little more fancy. Now let's put a wall, like, say, there. Yeah, let's do that. Okay, cool. No, it's not. C++ definitely doesn't do it at 1. It's more, does this library do it at 1? I don't think so. I think it's more just my math is miscalculating. And keep in mind, I'm using a canvas, but I'm definitely not positioning it correctly. So this is all hacks on hacks. All right, so we got ourselves this sweet little map. Now we're going to run the Dijkstra algorithm, and I'm going to put the map on top with the numbers. Okay. Okay, let's get some water. Yeah, so Rust will start at 0, but every time you access an array, you have to fight the borrow checker to use 0. So I don't think it's gonna help. So I think if you were to take this a bit more seriously, I'm gonna have to see how to encode this, but this is totally a bit set. I think you could write maps out as bit sets real easy if you're just using these. All right, so what we're going to do is run the Dijkstra algorithm on these two matrices. And what we should see is that as the tiles go away from the player, so the player is 0, then the numbers should increase. And anywhere that there's a wall, I'll set the wall, no, anywhere that's a wall, it should be 1, I think. So we'll see, but I think you can set the limit pretty high. And then the idea is anytime you have an enemy, right? Say the enemy's here. All you need to do is you do the Dijkstra map once where the character's there. And then the enemies just walk to the lowest number, any square near them that's lower than what they're at. So it's just a very efficient way of making the AI work without having to do pathfinding or anything. And then what you can do is you can say this is where the character is, and then let's say there's some gold here, and you want enemies to go after gold over that. And you kind of change the value. I think you make this a negative number to start, so then it'll get more weight. And so then the enemies will walk towards the gold and then walk towards the player. So we'll try both of those scenarios. Okay, so we got our map. We do. We then want to, instead of walls, let's do I guess we just draw the numbers. Okay, let me comment this out. Let's just do the thing and then draw the map. And I should just make a generic function for drawing the map. Maybe put it, I don't know, like in some file that tells me where to put things for maps. It could be like map.cpp. I'll have to see. Okay, so we're gonna do matrix. Let's go result equals input walls, and yeah, let's set limit to, well no, let's leave limit alone. Okay, and then we just replace this with, replace walls with result. And then instead of this, I think we're going to do format. Do I have format? I do not. Oh. Yeah. Oh, automod? Let me see. He streams. I mean, yeah, he's the content president, that's for sure. I think I got a sunburn yesterday. I was outside for a total of like maybe 20 minutes filling sandbags, and my pasty white ass got a sunburn. Format. Honestly, I just need to get the number. Yeah, let's do that. Result. J. No, I. J. Okay. No, that's incorrect. This is correct. Yes. This will print the number. That's it. Okay, cool. Okay, let me see. Yeah, I actually wear a hat. Here, let me show you the hat. Hold on. You'll laugh. You find out when you shave your head or you're bald, hats are essential. Like, you don't realize how much hair helps you. So I have this guy. So you go out, I do a lot of plein air painting. I go outside and paint. And eventually you just get to where like you just have to wear a big ass hat. But it's like, it has, does this one have it? No, I have other ones that have a neck thing. So you go like that, and then they have like a drape that comes down. So I'll like pull that down like this. So like, and it actually does an amazing job. Like, you don't even need much sunscreen. And then maybe just like some on my neck, yeah. So I wear this hat. We're gonna, and then sometimes I do it Aussie style. I thought this one had the neck drape. It must be a different one. So I don't really sunburn. Like, I'll get a little crispy, and then it'll turn dark really quick, and then I'm good. All right. Just need to make that format work. And if this works, then we just need an enemy. Has no member draw text. Serious? Oh, did I lowercase shit? I why did I do that? Must have fat-fingered Vim. Alright, let's see. Oh. Damn it. Figures. Let's dump map. It must be calculating that wrong. That's probably dying there. Or these don't have the same dimensions. I should probably do some asserts. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, they should be right. Yeah, that's totally the same dimensions. Yeah, I definitely should do an assert that make sure that they're the same dimension. Am I accessing this wrong? Okay, let's run that and see where it's bombing. I mean, the result looks good. Interesting. And it's setting the walls to 0. So I think you have to set limit to something. Because otherwise enemies would run towards the walls. You don't want them to do that. So you see what would happen is if you had an enemy here, they would go 7, 6, 5, 4, 3, 2, 1, 0. Alright, so how am I ganking this for loop? This for loop is causing problems. Am I too stupid to figure this out? Result is I, J. Should be good. And it actually works, so it does that. Let's set the limit. I have result 0. End result. Yeah, this is to get the width, basically. So the first row size. And this should get the length, or the, this one should be Y, and this one should be X. And so that's X, and that's Y, right? Is that what you're saying? Because each tile. Right, yeah. I really need to have, no, you're right. It's definitely something wrong with that. I'm not sure why, though. Okay, let me get rid of this. And let's do a limit. Well, no, let's leave that. It's like sort of working. Let's do a limit of 10. Now, we'll just do a limit of like 100. Yeah, so one of the dimensions I'm using is just wrong. Yeah, and this is kind of what we want to see. So 100 will represent something that it'll never try to go to. Like that. But see, I feel like that code is wrong real quick. Yeah, C++ complains if I don't do size t for the 2 dimensions. But let me just fix one thing real quick. And then we'll go back to that. Where's... Ah, this is interesting. Let me look in the Python code. When he makes that initial array, yeah, interesting. Very interesting. So if I move this up here, then the limit is just going to be the max dimensions. So nothing will ever go towards that because it'll be the max. So that'll make the test fail. But let me look what you got. No, size T is a type for using... It can't be... It's like a gigantic... It's basically this. Long unsigned int. But I'll get to that code and we can take a look in a second. Yeah, so those are going to be wrong, but... interesting. Yeah, so see, if you do that, then walls take the maximum value, so nothing will ever go there. I may make that change. Yeah, let's do that real quick. Okay, set the limit there, and then down here, this will be 16. Okay, let's make sure the test runs. No, size T is a type, and that's just a constraint of vectors. They'll accept integers, but then if you try to do math on it, C++ bitches and whines about it, so... Okay, so then that works. Now back to main. Alright, so for some reason I am just not doing this correctly. Alright, let's just let's make this a little bit easier to understand. We're going to change this to X and Y, because that's the actual dimensions. All right. So now, it's kind of weird to get like this wrong. X starts at 0. X length, the greatest length you can get. Is it post operator? Is that what I'm doing wrong? That shouldn't be it, but anyway. All right, we're gonna print this out. Let's just do that. We'll just see if it's like a 0, 0, 0, 0. Okay, good. That should be fine. Yep, confirm that works. Yep. Okay. It must be happening somewhere else. Yeah, it's gotta be happening somewhere else. Just a sec. Nope, yeah, it's something about that. The fuck, dude. So dumb. Yeah. Yeah, I don't know. So the result matrix seems to be off in some way. So I'll need some assertions and stuff to confirm that I'm getting what I'm supposed to. And also I need to okay. All right, let's take a look. Yeah, X size is 12, Y size is 5. What in the hell, man? God damn it. Yeah, let me I don't understand why GDB doesn't get a damn stack out of this. It's so dumb. Alright, I'll have to sort that out later. Alright, so let's access 50 right now. Also, why is it going to 0? Wait, am I just an idiot and I have these backwards? That's exactly what it is. I'm a dipshit. Yeah, because that accesses, this accesses that whole row, and then X accesses each inside there. Yeah, I inverted it. Okay. That makes more sense, I think. Yeah. I basically was doing it backwards. As the hurricane. The hurricane's, yeah. I'm really worried about the hurricane. Okay, I got something. Let me get rid of this garbage. Fantastic. Thank you for your assistance. Okay. That's obscene. Let's get rid of this. Okay, that's what we want to see. So it seems to miscalculate these, but I think that's okay. We can sort out why that is. It starts, let's say like an enemy starts here. Yeah. It's pretty, it's one of the reasons why using like an established matrix library is a good idea, because that shit's all just normalized. So if an enemy started here, it would go 1, and then it might go to this or that, then I go here, I go here, go here, go here, go here, and then find the enemy. Perfect. Now, most likely it's printing 6s and stuff because there's 16. So let's just say this is 10. Oh no, it's gotta be, yeah, hold up. There, that's more like it. Nice, yeah, so see, this is walls, that's wall, wall, very cool. So let's set this to 1000 for the limit, and then we go if, okay, so actually just do a ternary operator. Okay, cool, 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 cool. So that'll actually print wall. Yeah, it's kind of what I'm doing. Yes, you just pick some obscene value. So that's the map. So effectively, we've got ourselves some wall, we got that, we got the guy, enemy starts here. It just has to pick any square near it that is less where it's at. So that'd be 6, 5, 4. Then it can go 4, 3, 2, 1. Less than or equal to. Yeah, less than or equal to. So you have your path. Okay, so now let's try 2 objectives. Let's put, I say let's put gold here. And we're going to say it's like an enemy that will go get gold before attacking the player. Okay, so we're going to come up here. And we're going to do this as -1. Okay. I put that in the wrong place. No, that's right. Set it to 0, we'll see what it does. Okay, that worked, but -1 doesn't. Interesting. So yeah, so in this case, if an enemy is here, they'll go there, there. Then you update the map to not have that because they picked it up. And then they'll go there, 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 there. Yeah, cool. But -1 didn't work. Is it, you set this guy to -1? Let's try that. Hold on. Huh, that's weird. I mean, that does work. I may have to go read the description again. Because effectively, then the enemy would go there, 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 right? They do that. You update the map, and then it'll fix it so they go there, there, there. So why the fuck does -1 do that? Oh! It's interesting. I believe that's a bug because -1 gets translated into size T. A lot of those calculations. me try something. Yeah, I don't think that's going to work, but we'll see. Okay, so kind of the same effect. So the negative number is working. I'll have to go check the math. Yeah, it's unsigned, so I think we'll have to go I'll have to go look at the math. I guess the idea is... Yeah, it shouldn't be doing that at all. I mean, I think that's wrong. I could be right. They would still work, but I'd like to make sure that... Okay, let's do that, and then let's go into the map. Where are we actually doing calculations? No, it's just adding. It's not doing any kind of... Yeah, it's not doing any actual calculations using a size t or anything. Because all it's doing is just adding this integer. Right, so the counter goes up. It's just basically entering a counter in. Yeah, so that's what I was thinking. -1 would basically turn it into a gigantic number. Right? But then what we would see there is that would show up as, you would see it like a gigantic number there. We could test for that. We shouldn't see anything greater than 1,000. I think it's working correctly. I just think I might not understand exactly how it does it. So let's do -1 there. And then... let's do, let's do, all right, so if that goes off, that means that at some point that negative number was converted into a gigantic number because it became, it sign flipped and became unsigned. Oh, yeah. Oh yeah, let me see. No, this is like assert. So we want to check that this is always true. So every value has to be less than or equal to 1,000 because 1,000 is the wall. So if the sign was flipping and that was causing the output, then it would be close to what you just pasted. Right? And then the number you picked is basically unsigned numbers. They don't have a sign bit. Right, so the sign bit is, depending on the CPU, like the farthest left or farthest right bit. So when that one is set to 0, you get a normal number. Set to 1, it's negative. But then if you take one of those numbers and turn them into an unsigned number, just take the RAM and say it's unsigned, suddenly that becomes a maximum. Because you set the 1 there. So yeah, it's working correctly. So I guess what you do is if you want... So things that have lower priority have lower numbers. And then, in that case, let's look at it again. That's really cool. That's really cool that people figured that out. Okay, so then looking at the map... Yeah, so we have, let's say an enemy starts like right here. Like right next to the player. Are they going to go to the lowest number? I should, yeah, let me not draw the player. I want to see that condition too. Let's not draw the guy. right, so let's say they're here, right? Now, I think if they were close, I would add something in, because it'd be kind of ridiculous if they ran past the player to get the gold. But I would probably put something in the AI. If they can hit the player, they attack them. Let's say you don't do that. They could go to 9 or 8. So let's say they go 8, 7, 6, 5, all the way down to 0. They get the gold. Then the map flips, and it'll probably go 9, 8, 7, 6, 5, 4, 0 to where the player is standing. Smooth. That's actually really fun. Okay, so then let's try a few more key spots. Let's say there's also like something here. So enemies could go to like one of 2 locations. And then you can use different size numbers to change the priority. Yeah, so like let's say if the enemy was here, they would run to there. 1, 0. Change the map, it would probably be this one. So it'd be like 9, 8, 7, 6, 5, 4, 3, 2, 1 to there. And then they would go to the player. Yeah, that's slick. That's real slick. Let's try multiple numbers. So we want to do a priority. They go here first, then they go there, then they go here. So taking a look at the map, this is top priority, this is next priority, and this is the player. And let's bring the player back. Yeah. All right, so taking a look. Yeah, so they go here first. Let's say they pick that up. So we'll rebuild it without that. Then they should go back to here next and then over there. So then let's say they pick up the gold. So that becomes a 1. Oh, that completely screwed it up. Oh, because there's no 0. Ah, interesting. Okay, so yeah, so you'd have to then do decrement everything or increment everything. Yeah, so then they picked up the gold here. I think this 10, I'm going to throw in a little bit of logic to put a dot if it's over 9, because I think it's actually rendering a 10. But they go dun 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 dun. Yeah, they go like this and run past the player, grab that. Then you update the map again, and then they attack the player. Anyway, we'll just assume that's what's going on. Okay, so then update the map again. They picked this up. We have to increment 1 time. And then you see they'd be standing right here, so they go 1, 0. That's going to be 0. Fantastic. This works. It's so slick. I like it. It's such a clever way to handle it. All right, so we don't need this anymore. Let's get rid of that. Now this drawing algorithm is like totally jacked. We got to figure out how Canvas works. Like, how does Canvas work when combined with this? Where can we position it? I'm assuming because I'm using a renderer that I can actually alter the canvas. So maybe I can take all this, move it up into its own function. And then the renderer is just positioning it within a box or something. So we'll have to work on that. Okay, very cool. Now we got that. Okay. So the next thing is, we're getting kind of close to the end of this session. I'm going to do this for about 2 hours. But the next thing is map generation. So if we have map generation, we would just need to figure out how to divide this space. So we can probably do a tiny map of some kind, but the map generation algorithm that seemed to be the simplest was called BSP. All right. So the idea of that is you cut the space into 2 halves, basically making a binary search tree, right? And you cut them again and again and again. Then you have rooms. When you're done. And then you connect each room like that. And then you connect those pairs. And that gives you something. So that'll be the next thing we work on. I think we'll want to clean up the map class. Well, it's not even a class yet, but make a map class, and then we'll make a generator that can, given some parameters,